Hello class, we are now moving into our third section in this class, and basically everything we're going to do between now and the next test is going to be laying the groundwork for your guys' understanding of hypothesis testing, as well as making inferences from samples to populations. And one thing that's very important with both of those is the concept of a probability. So this is basically something that's key to that, particularly the hypothesis testing, which is the level that I really want you guys to understand this. But for the stuff we're going to cover today, we're really just or for this week, we're mostly just going to lay the groundwork for stuff that we're going to be doing later in this class, particularly next week and the week after that. But this stuff's going to hold true for pretty much the rest of the class, or this understanding that you'll have of this really help with that. But stuff we're going to look at with this particular unit, we're going to define probability, learn how to compute some simple probabilities, and maybe a few more advanced things. Okay, most of you are probably familiar with the term probability by this point in your lives. I mean, we use it all the time, and there's often things that we use. Okay, what's the chance that I could get a 2 when rolling a 6-sided dice? Or if you're a gambling person, you might ask, okay, what's the chance of getting a certain number on this roulette table? That's all something that's really you're really talking about probability there. Same thing when we're looking at the weather. What's the chance that it's going to rain today? And if the weatherman says it's an 80% chance, well, the reason he's got that notion is because he's dealing with probabilities that say that's what things are. So let's just go over some basics in reference to probability. You can generally think of probability as the likelihood that an event will occur. So mainly referring to what's the chances of a certain outcome happening, and that must be a single outcome happening. For example, you might ask yourself, what's the probability of drawing a one-eyed jack from a 52 card deck? Or what's the probability of heads in a coin flip? Or what's the probability of it snowing tonight? Those are all things that are dealing with probability. Now, just to get some more basic terminology out of the way, we call a set is when a group of outcomes or multiple events, what's the probability of those? It would be called a set. So the probability of pulling a jack and then an ace from a deck of cards would be talking about a set here. That's just some basic terminology out of the way. Some other stuff to get out of the way real quick. Throughout this unit and the rest of this class, whenever we're talking about probability as far as symbols and doing equations, we'll represent it by a lowercase p. And when we're talking about probability about a certain event, we'll call it probability, and then we'll have the event within parentheses. So the probability of event A occurring. This is what this would be representing. Alright, some more basics here. Calculating a probability is pretty straightforward and easy at the most basic level. It's basically just a fraction where you put the event of interest on top of that fraction and all other possible events on the bottom of that fraction. So, number of times event A can occur, and divide that by all possible outcomes. And we'll get through some examples here in a minute. Okay, just based on that simple formula I just gave you guys, that means the first thing we got to do when we're determining probabilities is determine the total outcomes that are possible. So for example, in a 52 card deck, if you're trying to determine what's the probability of pulling out a certain card or set of cards, well then that total outcomes would be 52. If you're in a dice roll, that total outcome would be 6, because you're using a 6-sided die anyway. Okay, next we want to actually figure out the actual number of possible occurrences for the event that we're looking at. So let's say that you want to draw, what's the probability of drawing a spade from a deck of cards? Again, we know our total outcome is 52, but how many spades do we have? Well, we have 13. So, if you wanted to find out the probability of drawing a spade from a deck of cards, we would divide the events by the total outcome, or basically divide, okay, the event that we're interested in, so drawing a spade, 13 here, by the total possible outcomes, which is 52, which would give us this probability of 0.25. Alright, let's go through another example real quick. That's pretty straightforward, so I think you guys probably have it already, but we'll just do one more example. So if we were looking at another thing, we often use its examples with these dice rolling. If we were looking at the probability of rolling a particular number on a single fair die, again it's got to be a fair die to mean that it's got an equal chance of every side coming up. So let's say we're interested in determining what's the probability of rolling a 2 using a single fair die. Well, I might give you guys a second now to try to figure this out on your own and calculate it. So if you want to, you might want to pause it now and calculate that real quickly to make sure you're on the right page here. Okay, so again, we got to figure out our stuff here. First, okay, we know the die has 6 sides. Total outcomes in the sample, so our total outcomes is 6. There's only one side that has a 2 on it, so that's the number of occurrences would be 1. So we just divide 1 by 6 and we end up with 0.1667. So our probability of rolling a 2 on a single fair-sided 6-sided dice would be 0.1667. And you can also think about that is we could convert that to a percentage and say we have a 16.67% chance of a 2 being rolled on a single fair die. Okay, just some more basic terminology here. There's going to be a lot of that in this chapter. But sampling and referring to probability, we have sampling with replacement and sampling without replacement. That just means sampling how many times are we going to basically test for the event that we're looking at. And sampling with replacement would be, okay, let's say we're interested again in our drawing a card from a 52 card deck. But when you're looking at this, basically you do it once, and then the second time you do it, so your second sample there, you actually, with replacement, you take the card that you drew and you put it back in. So that's pretty straightforward. So you draw a card from a deck, that's your first sample, your second sample, you draw another card, but let's say if it's sampling with replacement, then after the first drawing you put that card back, so your probability in the first time around is the same probability as your second sample, because you've replaced the card back in, and because you replaced it, just because you drew it on the first time doesn't change your probability of drawing the same card the second time around. So by that respect, sampling without replacement just simply means that we would draw the one card and not put it back in the deck for the second sampling. And basically, so that means our second sample would have a different probability of drawing a certain card than the first sample did. So pretty straightforward there. Sampling with replacement, you put it back, so each sample that you do doesn't affect the outcome of the next. Sampling without replacement, because you don't replace what you took out, it does affect your probability on your subsequent drawings or subsequent samples. Alright, moving on, because this is pretty easy at this level. So far so good, right? Well, let's go through some more terms that are important when we're dealing with probabilities. We're going to talk about independent events, non-independent events, mutually exclusive events, and exhaustive and non-exhaustive events. So independent and non-independent events are both dealing with how the occurrence of one event affects other events as far as probability. And with an independent event, it basically means that when you have an independent event, when that occurrence of one event happens, it has no effect on the probability of the occurrence of the other. So example here, if you're flipping a coin, if you get a heads one time, that's not going to have any effect on what you flip the next time. Same thing with rolling a die. If you roll a 2 on a fair die, that doesn't affect your roll on the next roll. So that would be, both of those would be considered independent events, because getting one outcome doesn't affect any other outcomes you might get. Now let's contrast this to a non-independent event, which is basically, again, the opposite. Whenever, essentially, this happens when different events are interrelated in some way, so that the occurrence of one event influences the occurrences of the other events. So an example of a non-independent event would be the probability of, say, your parents being tall and the probability of you being tall. Those are basically things that are affecting each other because you have genetics working there. Alright, mutually exclusive event. What does that mean? This basically means that two events are mutually exclusive when the occurrence of one basically completely excludes the possibility of another. So you can't have basically the same thing happening at the same time. Good example here again, if year you're in college would be an example. So you can't be obviously a sophomore and a junior. If you're one, you're excluded from being the other, so that would be a mutually exclusive event. Another example here, another term, exhaustive. This essentially means that a set of events represents all possible outcomes in the entire sample space. So again, if we looked at undergrad again, our event would be exhaustive if we included stuff for freshman, sophomore, junior, and senior. Again, you probably remember that term if you've had any research methods classes as far as how you make your survey questions. They need to be exhaustive and that they cover every category. Non-exhaustive obviously would be a set without all possible outcomes. It would be the opposite of exhaustive. So, for example, if we had graduate students, we do at this campus, if we included a set or sample of students that had basically non-graduate students in it, or was all non-graduate, and then there was no graduate students included, that would not be considered exhaustive. That's pretty straightforward. Again, exhaustive includes everything that's possible, non-exhaustive does not. So let's give an example of trying to figure out what characteristics a basic thing might fit. So let's look at, if we flip a coin, try to think, would that be exhaustive or non-exhaustive? Would that be mutually exclusive? All those things we just went over. Okay. First, let's look at, going back to what we looked at earlier, what are the possible events? Basically, two possible here, whether we get heads or tail. You can ask, are these events independent? Try to answer that yourself first. Yes, these are, because obviously you can't flip a coin, get a heads, and get a tails at the same time. So they would be considered independent. They're not dependent on each other. Are these events mutually exclusive? Once again, that's the case because you can't have heads and tails at the same time. Going back to independent again, flipping heads doesn't influence whether you flip a tails, or if you did multiple flips, it still wouldn't have any influence on it. Some people kind of think it does, and that leads to a lot of judgment errors and gambling, but really the probability is still the same every time you flip because they are independent. And then finally, is this exhaustive? Yes, there's only two categories, or there's only two possible outcomes, and both of those are represented by the coin flip. Okay, just as a quick note, a quick reminder here, or some stuff to add on to what we just covered. So we just kind of covered some of the very basics of probability, got some terms out of the way. One thing you want to remember about probability though is that it can only range from 0 to 1. You can't have a negative probability, and you can't have a probability higher than 1. And essentially how we would interpret that, the reason for that is because a 1 in probability represents a complete certainty that an event will happen, while 0 represents, for example, what's the chances of someone falling asleep watching this video? 100%. So no chance that's not going to happen. So that would be a 1 in probability. On the opposite end, 0 means it represents certainty that the event will not happen. So if we could say world peace is going to start tomorrow, that would probably have a probability of 0 because that's extremely unlikely and pretty much impossible. Obviously, most of the time you're going to get a number somewhere between 0 and 1. It's very rare to get a 0 or a 1 in probability because we're never that certain about things. There's always a level of uncertainty with most things. But with that in mind, I'll think that lower values, as far as probability go, represent a lower probability, and higher values closer to 1 represent a higher probability that an event will occur. Okay, just a few more things about probabilities, and then we'll move on to the next PowerPoint after that. But just some basic rules. Your book covers a few more than these, and you want to review those, but the very basic ones. The multiplicative law, or rule, this basically just means that if you have you can calculate the probability of two or more joint occurrences of independent events. And the way we do that is basically just the product of those individual probabilities. Meaning that, okay, let's better serve with an example. Let's say we want to get the probability of A and the probability of B after that. So the probability of A times probability of B for independent events. So essentially, best thing we can do for this example, what's the probability of rolling a 2 and then a 3 on a pair of dice? The key term here is and then. I'm kind of referring to this, that's when we should take this multiplicative law into effect, because it's asking, okay, how likely are we to get this one and then this one? So if we rolled it twice, what's that likelihood? And the thing we would do again under the multiplicative rule, because we're trying to figure out joint occurrences, we would basically, okay, what's the probability of getting a 2? That's 1.67. Again, 1 divided by 6 equals 1.67. Times that by the probability of getting a 3. Because these are independent, it's also 0.167. But you time those two together and you get 0.028. So that equals your probability of getting, if you're rolling a 6-sided dice twice, rolling a 2 and then rolling a 3. So you can also see that as a 2.8% of rolling a 2 and then a 3, 2.8% probability. But keep that in mind, multiplicative law, you use that when you want to determine the likelihood of getting one thing and then another. But these have to be independent events. Other example here, try to figure this one out on your own, but what's the probability that a coin flip lands on heads 3 times in a row? So I'll give you guys a second to calculate that. Well, we know that landing on it one time is 0.50, so that's our probability for one. But okay, 3 times in a row, 0.50 times 0.50 times 0.50. That actually gives us 0.125. You can read my writing there. Okay, let's do another one here, another example. What is the probability of drawing a jack and then an ace if you do not replace? So this one's a little trickier. If we don't replace, what's the basically thing here? So, okay, first we got to get the probability of drawing an ace, or a jack first. So that'd be 1 divided by 52, which basically equals 0.0192 if we're rounding. Sorry that this is really hard to read. But then, if it was okay, the probability of then getting an ace, well, since we don't put the card back, that would be 0.0196, slightly higher probability. But okay, times these two together, because we're seeing probability getting one then the other, and we get a probability of drawing an ace and then a jack of 0.00036. So a pretty small probability there. Okay, one more rule, a basic law here too, the additive law. This is basically used when we have a mutually exclusive set of mutually exclusive events, and we want to determine the probability of getting one event or the other. And the way we do this, we just sum the probabilities of the two separate events. So remember this, they have to be mutually exclusive, meaning that only one can occur at a time. But then you would be probability of the first event plus the probability of the second event would give you the probability of having one event or the other. And the key term here is, again, or. So, example here, key phrase, either or. Give you guys an example of this one. I think I skipped over it. So, we have this idea of what is the probability that I draw either a spade or a diamond from a 52 card deck. So probability of spade or diamond equals probability of spade plus the probability of drawing a diamond. So that would be 13 divided by 52 plus 13 divided by 52 equals 0.25 plus 0.25 equals 0.5. So roughly a 50% chance of drawing a spade or a diamond, which makes sense because that's basically making up half the deck at that point. Okay, I'll let you guys run through these examples here real quick. First one, what's the probability of rolling either a 4 or a 5 on a fair die? Second, what's the probability of getting either a heads or a tails on a fair coin? Okay, so the first one here, first we would get the probability of getting one of these, which we already calculated earlier. That would come out to roughly 1.67, or 0.167, sorry about that, 0.167. But then if we wanted to see, okay, and then rolling a 5, and then the probability of getting a 5, so we add those two together, and we would basically get 0.334. So that would be our chance of getting a 4 or a 5. This last one's the probability of getting either a heads or a tails. Again, we would use the additive rule. That one's pretty simple. Probability of getting a heads is 0.50. Probability of getting a tails is 0.50. So add those together. Obviously, there's only two outcomes here. Probability of getting one or the other is 1. So there's a 100% chance that we will get a heads or a tails on a fair coin. Okay. So this is going to end our first video for this unit. Just wanted you guys to get some basics on probability. The next video we're going to move into, we're going to talk about probability distributions and hypothesis testing. And the stuff we just covered here, this idea of probability forms the basics of that, but you're not going to need to know much of the math from this point on. But I do want you guys to know this basic math for this section for the next test. But from now on, the next PowerPoint in this section is going to be slightly different. I'm going to try to approach it from more a conceptual level. Alright, you guys might want to take a break, or you can just go and watch the next video right away.